Hi everyone, and welcome to your second video. We are finally moving away from graphing lines and onto something that I think is definitely more fun. We are going to be working with all different types of shapes in this chapter, chapter 6. And in the first section, we're going to be working with the angles of the shape. This is definitely one of my favorite chapters, and I definitely think it's going to be one of yours. Okay, so let's first talk about what a polygon is. A polygon is basically a fancy word for shape, minus, a circle, because you have to have at least 3 sides and 3 angles to be considered a polygon. So your first polygon is going to have to be a triangle. Now there's different types of triangles. We have scalene, we have isosceles, we have equilateral, but we're not going to get into those just yet. For now, all you need to know is that a triangle has 3 sides and 3 angles. The next shape is a 4-sided quadrilateral. The word quad means 4. Now, there's different types of 4-sided shapes. We have rectangles, squares, rhombuses, parallelograms, trapezoids. Then we can have a 5-sided shape called a pentagon, a 6-sided shape called a hexagon. What's not listed here is a 7-sided shape called a heptagon, an 8-sided shape called an octagon. Then we even have more than that. We have 9-sided shapes called nonagons, 10-sided shapes called decagons, and for all intents and purposes, all these fancy shapes, we're going to call them polygons. Okay? Now we need to know how to classify certain polygons so that when I say certain words in class, you know what type of polygon I'm talking about. If I say equilateral, equilateral, I'm talking about the lengths of all the length of whatever shape you have, they're all the same length. If I say equiangular, the word angle is in there, equiangular polygon, then I'm talking about a polygon that has all equal measurements, angles. If I say regular polygon, what I'm talking about is a polygon that has all equal length sides and all equal angles. Okay? For the purposes of this class, most of the time, not all the time, most of the time we're going to be working with regular polygons. Okay? Now, what we're going to be doing with these polygons is we're going to be finding the sum of their interior angles. Okay? If you have a 5-sided pentagon, it's going to have 5 angles. Now, how many angles are in a pentagon? Well, we don't know. Well, we can find out using this formula. Okay, an n in the formula is going to represent the number of sides that are in your polygon. So if we did have a 5-sided pentagon, we would put the number 5 right here in our formula, and it'll tell us how many angles in total is inside of our pentagon. Okay, so that's exactly what our first topic is, finding the sum of all interior angles of any polygon. So here's your first example. We're going to work on finding the sum of the interior angles of a hexagon. As you can see from the picture I gave you, a hexagon has 6 sides. Okay? Now, in order to find the sum of the interior angles of the hexagon, we have to use the formula we just talked about, where n represents the number of sides in the polygon. Since we have a hexagon and it has 6 sides, guys, it's so simple. All you got to do is put the number 6 right here in your equation where n is. Put the number 6 there and follow PEMDAS. You've been doing PEMDAS since middle school. Parentheses first, 6 minus 2, that's 4. Then you can multiply 4 times 180. You're going to get 720 degrees. So every single measure in your hexagon is going to add up to 720 degrees. Let me show you what I mean. This angle, this angle, this angle, this one, and this one. All 6 angles are going to add together to be 720 degrees. Okay? Let me go ahead and get my arrow back so we can move forward to the next one. Okay, let's try this one together. Now I'd like you to find the sum of the interior angle measures of an octagon. As you can see from the picture, you can count them up. An octagon has 8 sides, and we're going to have to use that formula again. One more time. N stands for the number of sides in any shape, in any polygon. So let me go ahead and get out my pointer here. Let's go ahead and plug in 8 right here. Okay, so we're going to have 8, since we have 8 sides, minus 2 times 180. We got to do PEMDAS, parentheses first. 8 minus 2, that's 6. 6 times 180. Go ahead and get out your calculator. That's a pretty big number to multiply there, okay? So the number we're going to get is 1,080 degrees. That is a degree symbol there, not another 0. That's just my computer typing for you. 1,080 degrees. That's a heck of a lot of degrees. That's because you have 8 angles. When you have an 8-sided figure, you're going to have 8 angles. And all of those angles will add together to be 1,080 degrees. Okay, so let me go ahead and get my pointer back. I think most of you are getting the hang of this. Here we go. All right, guys, this one's for you to do. So you're going to be able to find this question on Edmodo. On Edmodo, I want you to answer question number 1 so that you can get credit for watching this video. By answering question 1, I know that you've seen this video and that you know how to do this problem. So go ahead, pause this video. Well, the video is about to end. So once this video ends, guys, go to Edmodo, get on question 1, and go ahead and answer that one there for me, okay? So we're done with this video. The next video is going to be a new topic of this section. So when you're ready, go ahead and click on the next video. All right, see you soon. Bye.